If you enjoy untold stories of war and history, make sure to subscribe and join our journey through the past. May 8, 1945, Lechfeld Airfield, Bavaria. The unconditional surrender of German forces had been formalized the previous day. At Lechfeld, approximately 15 kilometers south of Augsburg, elements of the U.S. Third Army's 54th Air Disarmament Squadron arrived to survey captured Luftwaffe assets. The airfield had served as a primary operational base for Jägerschwader 7, the jet fighter unit designated Nowotny, after its fallen commander, Major Walter Nowotny. On the damaged concrete apron stood 12 Messerschmitt Me 262 aircraft in varying states of serviceability. German ground personnel, now functioning under American supervision, reported that 9 aircraft had been deliberately disabled by removal of critical engine components. 3 appeared operationally intact. The Me 262, designated Schwalbe by the Luftwaffe, represented the world's first operational jet fighter to enter combat service. Development had begun in 1938 under the leadership of Willy Messerschmitt, though production delays and competing priorities within the German High Command postponed operational deployment until July 1944. The aircraft's distinguishing feature was its swept-wing design, with wings angled at 18 degrees, and twin Junkers Jumo 004B1 axial flow turbojet engines mounted in the cells beneath the wings. Maximum speed was documented at approximately 870 kilometers per hour at 6,000 meters altitude. Operational range was limited to roughly 1,050 kilometers. Standard armament consisted of 4 Rheinmetall Borsig 108 Malawian Quach's 30mm cannons mounted in the nose, though American forces would remove these weapons during subsequent testing. Captain James R. Hazlip of the 54th Air Disarmament Squadron conducted the initial technical assessment on May 9. He recorded serial numbers, noted structural damage, and photographed each aircraft from multiple angles. One aircraft bore the tactical marking White 9 in large numerals on the fuselage nose. This particular example, work number 500491, showed minimal external damage and retained both engines. Hazlip's preliminary report, filed on May 11th, recommended preservation of 3 aircraft for technical exploitation. The recommendation specified that these aircraft should be transported to the United States for detailed examination and flight testing under the classified program designated Operation Lusty, an acronym for Luftwaffe Secret Technology. The operation had been authorized by Supreme Headquarters Allied Expeditionary Force in March 1945, anticipating the capture of advanced German aircraft. Colonel Harold E. Watson, a test pilot with extensive experience in captured enemy aircraft evaluation, commanded the Foreign Equipment Section responsible for selecting, recovering, and transporting German aircraft to American test facilities. Watson had assembled a team of pilots and engineers, informally known as Watson's Whizzers, who would ferry flyable German aircraft from Bavaria to collection points in France. By May 15, 1945, Watson's team had arrived at Lechfeld. Colonel Watson personally inspected the 3 Me 262 aircraft identified for preservation. The most complete example, White 9, became the primary candidate for immediate flight testing. German mechanics, former Luftwaffe personnel now employed as laborers, provided technical information regarding engine starting procedures, fuel requirements, and known operational limitations. The Jumo 004B1 engine required a specific kerosene-gasoline blend designated J2, which German forces had used as a substitute for conventional aviation gasoline due to wartime fuel shortages. American forces had limited supplies of J2 available at Lechfeld, obtained from captured German stocks. The first American attempt to start a Me 262 engine occurred on May 17. Technical Sergeant Robert L. Strabel, an engine specialist, supervised the procedure. The starting sequence required an external compressed air supply to rotate the turbine to minimum ignition speed. Once rotation reached approximately 1,000 revolutions per minute, fuel was introduced into the combustion chamber and ignited by a spark plug system. The starboard engine of White 9 started successfully after 2 attempts. Exhaust gas temperature stabilized at 650 degrees Celsius at idle power. The port engine failed to start on the first 3 attempts due to a blocked fuel line, which German mechanics cleared by partial disassembly of the fuel pump. Both engines operated simultaneously for approximately 8 minutes before being shut down to conserve the limited fuel supply. Colonel Watson made the decision to attempt a test flight at Lechfeld before disassembly and transport. This decision deviated from standard procedure, which called for ground transportation of captured aircraft to designated collection points. Watson's rationale, documented in his field report dated May 18, was that successful flight testing at the point of capture would provide immediate operational data and verify airworthiness before the lengthy process of disassembly and ocean transport. The risk of losing the aircraft to mechanical failure or pilot error was deemed acceptable given the intelligence value of actual flight performance data. On May 20, 1945, at 0815 hours, Colonel Watson conducted the first American flight of a Messerschmitt Me 262. Weather conditions were recorded as clear visibility, temperature 15 degrees Celsius, wind from the northwest at 12 kilometers per hour. Watson had studied captured German technical manuals translated by intelligence personnel and had received a briefing from a former Luftwaffe pilot, Oberleutnant Hans Fay, who had accumulated approximately 40 hours in the Me 262. Fay emphasized the critical importance of smooth throttle movement, explaining that rapid throttle advancement could cause compressor stalls and flameouts. He also warned that the engines required approximately 5 seconds to respond to throttle inputs, creating a significant lag that required anticipatory throttle management during approach and landing. Watson taxied the aircraft to the departure end of runway 27. The nose gear steering proved sensitive, requiring small rudder inputs to maintain directional control. At the hold point, Watson performed an engine run-up, advancing both throttles to approximately 75% power while holding the brakes. Engine instruments indicated normal operation. Exhaust gas temperatures remained within acceptable limits. Watson released brakes and advanced throttles to take off power. The acceleration was notably smooth compared to piston-engine fighters, with none of the torque-induced yaw typical of high-powered single-engine aircraft. The Me 262 became airborne after a ground roll of approximately 700 meters at an indicated airspeed of 180 kilometers per hour. Watson retracted the landing gear and maintained a shallow climb at 300 kilometers per hour. The flight plan called for a familiarization circuit of the airfield at 1,500 meters altitude, basic handling maneuvers including turns and speed changes, and a single landing. Watson reported that control forces were moderate, with the aircraft exhibiting neutral stability in pitch and slightly unstable characteristics in directional control at low speeds. Roll response was rapid, requiring less control input than American fighters of comparable weight. At 1,500 meters altitude, Watson conducted a series of turns at 30 degrees of bank. The aircraft maintained altitude with minimal back pressure on the control column. Increasing bank angle to 45 degrees resulted in modest altitude loss, approximately 50 meters per 360-degree turn. Watson then explored speed range, reducing power to idle and allowing speed to decrease while maintaining altitude. At approximately 220 kilometers per hour, the aircraft began to buffet, indicating approach to stall. Watson did not attempt to fully stall the aircraft on this initial flight. He advanced throttles smoothly and noted the 5-second lag before engine thrust increased noticeably. The flight duration was 18 minutes. Watson entered the traffic pattern at 1,200 meters altitude and configured the aircraft for landing, lowering the landing gear and extending the split flaps to the landing position. Approach speed was maintained at 240 kilometers per hour. The Me 262 exhibited a tendency to float during the flare, finally touching down approximately 400 meters beyond the runway threshold. Watson deployed the brake parachute, which arrested the aircraft's momentum effectively, bringing it to a stop with minimal brake application. Watson's immediate post-flight assessment, recorded in a field report dated May 21, noted several significant observations. The jet engines provided smooth, vibration-free power compared to piston engines. Acceleration was inferior to American fighters at low speeds but became progressively better as speed increased above 400 kilometers per hour. The swept-wing design appeared to provide favorable high-speed characteristics, though Watson had not explored the aircraft's maximum speed envelope during this conservative first flight. The engine throttle lag presented a significant challenge during speed control and required constant pilot attention. Overall handling was assessed as acceptable but demanding, requiring more precise pilot technique than contemporary American fighters. Between May 21st and May 28th, additional flights were conducted by two other members of Watson's team. Captain Robert Straubel, despite his primary role as an engine specialist, was also a rated pilot and flew White 9 twice, focusing on engine behavior at various power settings and altitudes. He documented that the Jumo 004 engines operated most efficiently between 3,000 and 6,000 meters altitude, where exhaust gas temperatures remained within optimal range and fuel consumption was minimized. Above 7,000 meters, engine performance degraded noticeably, with reduced thrust and increased tendency toward flameout if throttles were manipulated abruptly. Major Fred Wolfe, an experienced test pilot, conducted a comparative speed run on May 26. Flying at 6,000 meters altitude, he advanced throttles to maximum continuous power and allowed the aircraft to accelerate in level flight. Maximum indicated airspeed reached 535 kilometers per hour, which corresponded closely to the German performance specifications. Wolfe noted that the aircraft remained stable at maximum speed with no tendency toward pitch changes or control difficulties. This represented a significant speed advantage over the North American P-51 Mustang, which achieved approximately 440 kilometers per hour maximum speed, and the Republic P-47 Thunderbolt, which reached approximately 430 kilometers per hour. By the end of May 1945, the decision was made to transport three Me-262 aircraft to the United States for comprehensive testing. White 9 and two additional examples, designated FE-4010 and FE-4011 in the American Foreign Equipment Inventory System, were selected. The aircraft would be partially disassembled, crated, and shipped from France to the United States. Colonel Watson designated Freeman Field, Indiana, and Wright Field, Ohio, as the primary test locations. Freeman Field possessed adequate runway length for jet operations and maintained a specialized foreign equipment flight test facility. Wright Field, the Army Air Force's principal research and development center, would conduct detailed technical analysis of the aircraft and engines. The disassembly process began at Lechfeld on June 1. German civilian workers, supervised by American engineers, removed the wings from each aircraft at the main spar attachment points. The engines remained mounted to preserve the installation configuration and associated systems. Each component was wrapped in protective materials and placed in wooden crates constructed to specific dimensions for transport aboard U.S. Navy vessels. The work proceeded methodically, photographically documented at each stage to facilitate reassembly in the United States. On June 15, the crated Me-262 components departed Lechfeld by truck convoy, traveling northwest through Munich and Stuttgart to the French port of Cherbourg. The journey required 4 days due to damaged roads and multiple checkpoints. At Cherbourg, the crates were transferred to the USS Reaper, a small escort carrier designated 9-275, which had been converted to aircraft ferry service. The Reaper departed Cherbourg on July 2, 1945, carrying not only the Me-262 aircraft but also examples of the Focke-Wulf FW-190, Messerschmitt Bf-109, and several other German aircraft types. The Atlantic crossing required 13 days, with the vessel arriving at Newark, New Jersey, on July 15. From Newark, the crates were transported by rail to Wright Field, arriving on July 22, 1945. Reassembly began immediately in Hangar 4 of the Foreign Equipment Section. The work was supervised by Mr. Kenneth Chilstrom, a civilian engineer with extensive experience in aircraft structures. German technical manuals, captured along with the aircraft, provided assembly instructions, though these had been written in German and required translation. The reassembly process revealed several aspects of German wartime manufacturing. Many components showed evidence of simplified production methods, with hand-fitted parts and minimal use of precision tooling. Riveting was generally adequate but inconsistent compared to American manufacturing standards. Surface finish was rough in areas not critical to aerodynamic performance. The Jumo 004B-1 engines received particular attention during reassembly. Each engine was partially disassembled for inspection by propulsion specialists from the power plant laboratory at Wright Field. The axial flow compressor consisted of 8 stages, with steel blades rather than the aluminum alloys used in contemporary American engine development. The combustion chamber design was simple, consisting of 6 flame tubes arranged around the engine centerline. The single-stage turbine, which extracted energy from exhaust gases to drive the compressor, employed blades made from a chromium steel alloy. American metallurgists noted that this material was inferior to the nickel-based superalloys being developed for U.S. jet engines, explaining the JUMO 004's limited service life of approximately 20 to 25 hours before requiring complete overhaul. The engine inspection report, completed on August 10, 1945, and classified secret, concluded that the JUMO 004 represented a pragmatic approach to jet propulsion under severe material constraints. The design emphasized manufacturing simplicity and use of available materials rather than optimal performance or longevity. German engineers had achieved functionality despite lacking access to strategic materials such as nickel and cobalt, which were essential for high-temperature applications. The report noted that American jet engine development, particularly the General Electric I-40 turbojet being developed for the Lockheed P-80 Shooting Star, benefited from superior materials and more precise manufacturing, resulting in engines with significantly longer service life and better reliability. Reassembly of the first Me-262 at Wright Field was completed on August 28, 1945. The aircraft, now designated FE-4012 in American records, received U.S. military markings. The German Bokenkreuz was painted over, and the standard White Star insignia of the U.S. Army Air Forces was applied to the fuselage sides and upper left and lower right wing surfaces. The tactical number 12 was painted on the vertical stabilizer. On September 5, the aircraft was moved to the flight line for engine ground runs and systems checks. The first engine start at Wright Field occurred on September 7. The procedure required an external air start unit to spin the engines to starting speed. Fuel was the same J2 kerosene blend used in Germany, which had been synthesized from available petroleum stocks to approximate the German specification. Both engines started successfully and ran for 20 minutes at various power settings while instrumentation recorded exhaust gas temperatures, turbine speeds, and fuel flow rates. The data confirmed that the engines operated within expected parameters. Colonel Albert Boyd, chief of the Flight Test Division at Wright Field, was designated to conduct the first flight of FE-4012 on American soil. Boyd possessed extensive test pilot experience and had previously flown the Bell XP-59 Aerocomet, America's first jet aircraft, and had recent experience with the Lockheed P-80. His flight in the Me-262 was scheduled for September 12, 1945. Weather conditions were favorable, with clear skies, temperature 21 degrees Celsius, and wind from the south at 8 kilometers per hour. Boyd's takeoff occurred at 1,030 hours. The aircraft accelerated normally and became airborne after approximately 750 meters of ground roll. Boyd climbed to 3,000 meters altitude and spent 35 minutes conducting handling qualities assessment, including turns, climbs, descents, and speed variations. He explored the aircraft's speed range more aggressively than Colonel Watson had done in Germany, accelerating to approximately 700 kilometers per hour in level flight at 5,000 meters altitude. At this speed, the Me-262 remained controllable, though Boyd noted slight buffeting and increased control forces. Boyd's post-flight report, filed on September 13, provided a detailed comparison with American jet aircraft. He noted that the Me-262's swept-wing design appeared to delay the onset of compressibility effects at high speed, allowing the aircraft to operate closer to the speed of sound than contemporary straight-wing jets. The P-80, with its straight wings, experienced significant buffeting and control difficulties above 650 kilometers per hour. Boyd hypothesized that swept wings might represent the future standard for high-speed aircraft design. This observation would prove influential in the development of subsequent American fighters, particularly the North American F-86 Sabre, which incorporated a swept-wing design directly influenced by German research. Additional flights through September and October 1945 focused on specific performance parameters. Lieutenant Colonel Fred Borsotti, a civilian test pilot working under contract to the Army Air Forces, conducted a series of climb performance tests on October 3. He established that the Me-262 could climb from sea level to 6,000 meters altitude in approximately 8 minutes under standard atmospheric conditions. This climb rate was superior to American piston engine fighters but slightly inferior to the P-80, which achieved the same altitude gain in approximately 7 minutes. However, the Me-262's superior maximum speed partially compensated for its modest climb performance. Engine reliability emerged as a significant concern during the American test program. On October 17, 1945, during a routine test flight by Major Robert Straubel, the port engine of FE-4012 suffered a compressor blade failure at 4,500 meters altitude. The blade separation caused severe vibration and loss of thrust. Straubel immediately reduced power on the affected engine and declared an emergency. He landed successfully on the starboard engine alone, demonstrating that the Me-262 possessed adequate single-engine performance for emergency situations. Post-flight inspection revealed that a compressor blade had fractured due to fatigue, likely caused by poor material quality or manufacturing defects. The damaged engine was removed and replaced with a spare Jumo 004 that had been shipped with the aircraft from Germany. The incident prompted a comprehensive review of engine maintenance procedures and operational limitations. Wright field engineers established mandatory inspection intervals and recommended maximum power limitations to extend engine life. These restrictions, documented in Technical Order FE 4012-1 dated October 25, 1945, specified that engines should not operate above 90% maximum power for more than 5 minutes continuously, and total engine operating time should not exceed 20 hours before removal for inspection and potential overhaul. Throughout late 1945, comparative testing continued with other jet aircraft. On November 8, a side-by-side evaluation was conducted with a Gloucester Meteor Mk3, a British jet fighter that had entered service with the Royal Air Force in mid-1944. The Meteor had been provided to the United States under mutual information exchange agreements between allied nations. Test pilots flew both aircraft on the same day under identical atmospheric conditions, conducting speed runs, climb tests, and handling maneuvers. The results, compiled in a classified report dated November 20, 1945, indicated that the Me-262 and Gloucester Meteor possessed similar maximum speeds, approximately 870 km per hour for the Me-262 and 840 km per hour for the Meteor Mk3. The Me-262 exhibited superior high-speed handling due to its swept wings, while the Meteor's straight-wing design provided better low-speed characteristics and landing qualities. Both aircraft suffered from similar engine reliability issues, though the Meteor's Rolls-Royce Derwent engines demonstrated somewhat longer service life than the German Jumo 004. By December 1945, attention shifted to detailed aerodynamic analysis. Engineers from the National Advisory Committee for Aeronautics, the predecessor organization to NASA, arrived at Wright Field to conduct wind tunnel testing using scale models constructed from measurements of the actual Me-262. The NACA team included Theodore von Karman, a prominent aerodynamicist who had been instrumental in advancing American understanding of high-speed flight. Von Karman's team conducted tests in the Wright Field wind tunnel facility, measuring pressure distributions over the wing and fuselage at various angles of attack and speed regimes. The wind tunnel data, analyzed through early 1946, confirmed that the swept wing design significantly reduced the drag rise associated with approaching the speed of sound. At subsonic speeds approaching Mach 0.8, the Me-262's wing experienced less dramatic drag increase than straight wings of similar area and thickness. This finding validated the theoretical work of German aerodynamicists, particularly Adolf Busemann, whose research on swept wings dated to the 1930s but had not been widely implemented until the Me-262 program. The NACA report, published in March 1946 as Technical Note 1005, became foundational literature for American swept-wing research and influenced the design of numerous subsequent aircraft. The test program at Wright Field continued through the spring of 1946, though flight activity decreased as the accumulated flight hours approached the safe operational limits of the Jumo 004 engines. By April 1946, FE 4012 had accumulated approximately 32 flight hours across 43 separate flights. The engines were approaching the end of their useful life, and replacement engines from the limited stock of captured Jumo 004s were being reserved for other research purposes. A second Me-262, designated FE 4010, had been reassembled at Freeman Field, Indiana, and entered flight testing in January 1946. This aircraft was used primarily for pilot familiarization and training, allowing additional Army Air Forces pilots to gain experience with jet operations. Among the pilots who flew FE-4010 were several who would later become prominent in jet aviation development. Captain Charles E. Yeager, who would achieve fame in 1947 as the first pilot to exceed the speed of sound in the Bell X-1, flew FE-4010 on February 14, 1946. His brief flight report noted that the Me-262 provided valuable experience with jet propulsion characteristics that differed fundamentally from piston engines. On March 27, 1946, FE-4010 experienced a serious incident during takeoff from Freeman Field. The pilot, Major Melvin Apt, a test pilot with extensive experience in high-performance aircraft, had just released brakes and begun the takeoff roll when the port engine suffered a catastrophic failure. The compressor disintegrated, sending fragments through the engine nacelle and puncturing the wing fuel tank. Fuel from the ruptured tank ignited immediately, creating a severe fire. Apt aborted the takeoff, steering the aircraft off the runway onto the grass-overrun area. He shut down both engines and evacuated the aircraft before the fire spread to the main fuselage fuel tank. The aircraft was destroyed, though Apt escaped without injury. The Accident Investigation Board, convened on April 2, determined that the engine failure resulted from material fatigue in a compressor rotor, similar to the failure experienced by FE-4012 the previous October. The loss of FE-4010 effectively ended the operational testing phase of the Me-262 program. By mid-1946, the Army Air Forces had extracted the essential performance and handling data from the captured aircraft. The surviving examples, including FE-4012 at Wright Field, White 9 at Freeman Field, and FE-4011, which had been partially assembled but never flown, were transferred to storage pending decisions regarding their final disposition. In June 1946, a comprehensive technical summary was prepared by the Foreign Equipment Section at Wright Field. This classified document, designated Report Number FE-1004 dated June 18, 1946, synthesized all data collected during the 15-month test program. The report ran to 247 pages and included detailed performance charts, engine analysis, aerodynamic data, pilot comments, and photographic documentation. Key conclusions included the assessment that the Me-262 represented an advanced aerodynamic design that demonstrated the viability of swept wings for high-speed flight. The JUMO 004 engine, while crude in materials and construction, validated the axial flow turbojet concept and provided valuable data regarding the challenges of operating jet engines under field conditions. The report specifically noted several areas where German technology had surpassed Allied development at the time of capture. The swept wing design was more sophisticated than any Allied aircraft in operational service in 1945. The integration of jet engines into a practical combat aircraft had been achieved earlier and more successfully than the American XP-59 or the British Gloucester Meteor. However, the report also emphasized German shortcomings, particularly in materials science and manufacturing quality control, which limited the operational effectiveness and reliability of the Me-262 despite its advanced design. The technical data obtained from the Me-262 program influenced several American aircraft development efforts then underway. The North American Aviation Company, which was designing a New Day fighter for the Army Air Forces, modified its design to incorporate swept wings after reviewing the Me-262 data and captured German research documents. This aircraft would emerge as the F-86 Sabre, which entered service in 1949 and became one of the most successful fighters of the early jet age. Similarly, Boeing's design for the B-47 Stratojet bomber incorporated swept wings, a decision directly influenced by German research. The B-47 first flew in December 1947 and revolutionized bomber design. Engineers who examined the Me-262's engines contributed to American turbojet development through the mid-1940s. While American engines benefited from superior materials, the simplicity and practicality of the JUMO 004 design influenced thinking about turbojet architecture. The General Electric J-35 and J-47 engines, which powered the F-84 Thunderjet and F-86 Sabre respectively, incorporated lessons learned from studying the JUMO 004, particularly regarding combustion chamber design and turbine cooling. By late 1946, The remaining intact Me-262 aircraft were assigned to permanent storage or museum display. FE-4012, the most extensively tested example, was transferred to the National Air Museum, the predecessor institution to the Smithsonian National Air and Space Museum, in September 1946. The aircraft was placed in storage at the museum's facility at Park Ridge, Illinois, awaiting eventual restoration and public display. This particular aircraft remains in the Smithsonian collection today, though it was later restored using components from multiple Me-262 examples. White 9, the aircraft that Colonel Watson had first flown in Germany in May 1945, remained at Freeman Field through 1946 before being moved to Wright Field for long-term storage. Its engines were removed for continued laboratory study, and the airframe was used for structural testing, including landing gear load tests and wing stress analysis. By 1948, this airframe had been substantially dismantled, with various components distributed to educational institutions and research facilities for study purposes. FE-4011, which had never been fully reassembled for flight testing, was transferred to the U.S. Air Force Museum at Wright-Patterson Air Force Base in 1947. This decision reflected the newly formed U.S. Air Force's interest in preserving significant historical aircraft. The Air Force had been established as an independent service on September 18, 1947, separating from the Army. The museum, which had originated as a small collection of historically significant aircraft at Wright Field, would eventually become the National Museum of the United States Air Force, one of the world's largest aviation museums. Several Jumo 004 engines were retained for continued study and were sectioned for display purposes, allowing engineering students and researchers to examine the internal construction. One such sectioned engine was provided to the Massachusetts Institute of Technology for use in their aeronautical engineering program. Another was sent to the California Institute of Technology, where Theodore von Karman's team continued research into high-speed aerodynamics and propulsion. The final official flight of a Me-262 in American markings occurred on August 19, 1946, when test pilot Fred Borsodi flew FE-4012 for one final data collection sortie before the aircraft's retirement. The flight lasted 22 minutes and consisted of a series of photographic passes at low altitude, allowing ground cameras to record the aircraft in flight from multiple angles for archival purposes. Borsodi reported normal aircraft and engine operation throughout the flight. After landing, the engines were shut down for the final time, and the aircraft was prepared for transport to the National Air Museum. In the years following the end of active testing, occasional requests arose for additional flights or tests of the Me-262, but these were generally denied due to the lack of serviceable engines and the historical value of the surviving airframes. By 1950, no flyable Me-262 aircraft remained in American hands, though several examples existed in various states of preservation in museums and storage facilities. The technical and operational knowledge gained from the Me-262 program contributed to American aviation development throughout the late 1940s and early 1950s. The swept-wing concept became standard for high-speed aircraft, appearing not only on fighters and bombers but also on research aircraft such as the Bell X-2 and Douglas X-3. The experience gained operating and maintaining jet engines under field conditions informed the development of improved maintenance procedures and pilot training programs for the growing fleet of American jet fighters entering service. Several of the pilots and engineers who participated in the Me-262 test program went on to significant careers in aviation. Colonel Harold Watson continued as a test pilot and eventually rose to the rank of brigadier general before retiring from the Air Force in 1966. His leadership of Operation Lusty and the subsequent testing of captured German aircraft earned him recognition as a pioneer in the field of foreign equipment exploitation. Fred Borsodi continued as a civilian test pilot for NACA and later NASA, contributing to numerous research programs through the 1960s. Charles Yeager's experience with the Me-262 provided background for his later work as a test pilot on the X-1 program and his historic breaking of the sound barrier on October 14, 1947. The historical significance of the Me-262 testing program extends beyond the immediate technical data collected. The program represented one of the first systematic efforts by American military aviation to analyze and integrate foreign technological developments into domestic research and development. The methodology established during Operation Lusty, including the careful documentation, preservation, and testing of captured equipment, became a template for subsequent foreign equipment exploitation programs during the Cold War era. Academic researchers and historians have extensively studied the Me-262 program through examination of the original test reports, pilot accounts, and technical documentation preserved in military and civilian archives. The National Archives facility at College Park, Maryland, houses the complete set of foreign equipment test reports from Wright Field, including report number FE-1004 and numerous supporting documents. These records were declassified in stages beginning in the 1970s and became available to researchers, enabling detailed historical analysis of the program. The metallurgical studies of the Jumo 004 engine proved particularly valuable for understanding German wartime industrial capacity and material shortages. Analysis revealed that German engineers had developed innovative solutions to compensate for the lack of strategic materials, including the use of ceramic coatings on turbine blades to improve heat resistance and the substitution of mild steel for higher-grade alloys in non-critical applications. While these expedients limited engine life and reliability, they demonstrated remarkable engineering ingenuity under severe constraints. Aerodynamic research derived from the Me-262 contributed to theoretical understanding of transonic flight, the regime between subsonic and supersonic speeds where airflow over portions of an aircraft may exceed the speed of sound even though the aircraft itself remains subsonic. The swept-wing configuration demonstrated by the Me-262 helped delay the onset of shock wave formation on the wing, postponing the dramatic drag rise and control difficulties associated with transonic flight. This principle became fundamental to the design of high-speed aircraft throughout the jet age. The influence of German jet technology, as exemplified by the Me-262, on American aviation development has been a subject of scholarly debate. Some historians emphasize the direct transfer of specific technical solutions, such as swept-wing geometry and axial flow engine architecture. Others argue that American aviation would have independently developed similar solutions given sufficient time and resources. The documentary evidence suggests that German technology accelerated American development in certain areas by several years, particularly in swept-wing applications, while in other areas such as engine materials and manufacturing techniques, American practice was already superior or rapidly advanced beyond German achievements. By the early 1950s, the Me-262 had largely faded from operational relevance, superseded by more advanced jet fighters with greater speed, improved handling, and reliable engines. The Korean War, beginning in June 1950, demonstrated the effectiveness of swept-wing jet fighters when the F-86 Sabre achieved air superiority against Soviet-built MiG-15 fighters. The MiG-15, like the F-86, employed swept wings influenced by German research. This convergence of design features among former Allied and Axis powers illustrated how German aeronautical knowledge had dispersed internationally through various channels, including captured documents, recruited scientists, and independent analysis of captured hardware. The final disposition of Me-262 components from the American test program varied. Engines were distributed to universities and technical schools for instructional purposes. Airframe sections were used in structural testing programs, gradually consumed by destructive tests. Complete aircraft assigned to museums underwent varying degrees of restoration depending on institutional resources and priorities. The Smithsonian's FE-4012 received a comprehensive restoration beginning in the 1970s, though the work required decades to complete due to the complexity of locating authentic components and the need for specialized conservation techniques. Contemporary research continues to examine aspects of the Me-262 program using modern analytical techniques. In recent years, researchers have used computational fluid dynamics to model the Me-262's aerodynamic characteristics, comparing the results with the original wind tunnel data from 1946. These studies have generally validated the accuracy of the early analyses while providing additional detail regarding airflow patterns and pressure distributions. Such research contributes to the broader understanding of aeronautic history and the evolution of high-speed flight technology. The archival photographic record of the Me-262 testing program provides valuable documentation of mid-1940s test procedures and facilities. Photographs show the aircraft in various stages of disassembly, assembly, and testing, offering insights into the tools and methods available to engineers of that era. Images of instrumentation and data recording equipment illustrate the relatively primitive state of measurement technology compared to modern standards. Yet the data collected proved sufficiently accurate for engineering purposes and influenced aircraft design for years afterward. Written pilot reports from the Me-262 test program reveal the subjective experience of flying an early jet aircraft. Pilots consistently noted the smoothness and lack of vibration compared to piston engines, the substantial throttle lag requiring anticipatory power management, and the unusual sensation of thrust without a visible propeller. These accounts provide historical perspective on the transition from piston to jet propulsion and the learning curve experienced by pilots adapting to fundamentally different aircraft behavior. The educational value of the Me-262 program extended beyond immediate technical applications. The program demonstrated the importance of systematic testing and documentation in extracting maximum value from foreign equipment. It validated the concept of foreign equipment exploitation as an intelligence-gathering method and established procedures that would be refined and expanded in subsequent decades. During the Cold War, American forces would apply similar methods to captured Soviet aircraft and equipment, building on the foundation established during Operation Lusty. From a historical perspective, the American testing of the Me-262 represents a moment of technological transition, occurring at the boundary between the piston engine era that had dominated aviation for 4 decades and the jet age that would transform military and civilian aviation in the post-war period. The aircraft itself embodied this transition, combining advanced aerodynamic concepts with crude material execution, reflecting both the possibilities and limitations of technology development under wartime conditions. The final technical assessment of the Me-262, as documented in the classified summary reports of 1946, characterized the aircraft as years ahead in aerodynamic design but limited by inadequate materials and manufacturing capability. This conclusion reflected the broader reality of German technological development during World War II, where innovative design often outpaced the industrial capacity to produce reliable, maintainable equipment in quantity. The contrast with American industrial practice, which emphasized robust manufacturing and maintainability alongside performance, highlighted differing approaches to military technology development. By 1947, active involvement with the Me-262 had ended. The surviving aircraft rested in museums and storage facilities. Their operational careers concluded after brief but intensive evaluation. The engines had been disassembled and studied, the aerodynamic data analyzed and integrated into new designs, the lessons learned and applied to the next generation of American military aircraft. The hangars that had housed the testing program returned to other uses, the specialized equipment was reassigned, and the pilots and engineers moved forward to new projects and new aircraft that would push performance boundaries beyond what the Me-262 had achieved. The historical record of the Me-262 testing program exists in official reports, pilot logbooks, photographic archives, and surviving hardware preserved in museum collections. These materials provide documentation of a systematic technical evaluation conducted during the immediate post-war period, when American aviation was rapidly absorbing foreign technology and transitioning to jet propulsion. The program's influence on subsequent aircraft development is evident in the swept-wing designs that became standard for high-speed aircraft and in the operational procedures developed for jet engine maintenance and pilot training. In conclusion, the American testing of the Messerschmitt Me 262 from May 1945 through late 1946 constituted a significant technical intelligence operation that yielded valuable aerodynamic and propulsion data. The program demonstrated the effectiveness of systematic foreign equipment evaluation and contributed directly to American aircraft development in the early jet age. The aircraft tested, though limited by material constraints and reliability issues, exhibited aerodynamic sophistication that influenced fighter and bomber design for the subsequent decade. The knowledge gained informed the development of swept-wing aircraft including the F-86 Sabre and B-47 Stratojet, contributing to American air superiority during the Korean War and the broader Cold War period. The program established methodologies for foreign equipment exploitation that would serve American military intelligence for decades afterward. The surviving aircraft and extensive documentation preserved in archives continue to provide historical and educational value, offering insight into the technological transition that marked the immediate post-war era. The test program ended not with dramatic conclusions but with the quiet transfer of aircraft to museums and storage, the filing of final reports, and the movement of personnel to new assignments. The hangars fell silent, the engines stilled permanently, and the Me-262 passed from operational relevance into historical significance, its brief moment of evaluation complete, its technical secrets absorbed and surpassed by the rapid advancement of jet aviation in the years that followed.